So in this video, we're going to look at coronavirus pandemic as data science point of view. We're going to use updated data set related to 12th of March 2020, and we are going to use Jupyter Notebook in order to answer some leading questions like what is the dynamics of the pandemic, the death rate, and the infection rate. Also, we're going to find out the correlation between the infection and the death rate. Stay tuned. Hello and welcome. My name is Emmet, and here with me my buddy Sanchayan.
Hey guys, we are going to discuss the pandemic from the data science point of view. We have found some updated real-time data on Jupyter.
Actually, there is a link in the description below where you can find it updated day by day. Okay, Sanchayan, tell me about this data.
Okay, so we have the data now open in Excel. So you see there are a couple of columns. The first column is the province or the state. The second is the country and region. Then you have latitude, longitude, and the date of the infection or the death. Then you have cases related to that country and the specific person. And then you have two types. One is confirmed and another is death.
Okay, using this data, what sort of question we're going to answer, Sunshine?
There are mainly three types of leading questions people are facing at this moment. So basically, what is the dynamics of the pandemic?
Which means
The number of cases day by day. So then we have the number of deaths, then the number of confirmed rates. But basically what we want to see is how this number every day is changing with time. Let's say for the number of deaths that changing every time day by day. Then you have the number of infection.
Yeah.
And finally, what we are going to do, we will actually try to relate those two rates.
Okay, now let's jump to the Jupyter Notebook and get it started. Okay, so this is the code I wrote. You can find it on a GitHub. There is a link in the description below. So firstly, I import some modules that I'm going to use: Pandas, NumPy, Matplotlib, and Cbur. And secondly, I load the data set that we have in CSV format. So this is the data frame related to our data set. Okay, so as the first question, we have what is dynamics of the pandemic? In order to answer this question, we need number of confirmed cases grouped by the date, and also number of deaths cases grouped by the date. Okay, so in order to get these two informations, I wrote some codes. Here, I got the number of confirmed cases grouped by the date. Here we can see that. And this is the data frame related to this information. And also you can find it here, that number of deaths cases grouped by the date. And here you can see I have the information I need. And then if I plot this data, here you can see the plot that we have. Okay, Sanchayan, tell us about this data. What sort of information this plot will give us?
So you see this graph, it shows that it started with 22nd January till 12th March. So you see the number of cases, it fluctuates with time. And you see a jump, a very big jump, around 14,000 confirmed cases, which is very, very, very unfortunate, around 11th February. But you see the number of deaths also jumped, but you cannot see it here properly because the line is too flat, because the number of people dying is less with respect to the number of infected people.
So you mean that we cannot see enough details about this graph?
Yeah, so basically what we have to do, we have to consider a log curve.
A log curve?
Yeah, so the log curve means we have to take a log of the total number of cases.
It means that we can see more details in this.
If you consider the log curve, then you will see much more details.
Yeah, I mean the changes over the time every day.
Yeah, and hopefully you can relate those two graphs
together. Okay, so we will do it.
Yeah.
As Sunshine mentioned, we can calculate or let's say make a log curve related to these two plots or these two graphs. As you can see here, we have a plot with a log curve or log of total number of people.
Now you can see the relation. These two curves, they're pretty similar to each other. You see this ridges, these jumps and these valleys, which are pretty similar to this curve.
Yeah.
And you see when it started, we have the confirmed cases, we have the log curve, the scale is in log, but you see the pattern is pretty similar here. So, which I believe, if you now calculate the rate of this confirmed cases and the rate of death every day, so you are calculating the rate. I think we can find some much more interesting information from that.
Okay, so here we can calculate the correlation coefficient between these two graphs. I use the NumPy modular to find it out. So here it says that we have 65% correlation between these two graphs. What does it mean?
So as you see, this correlation coefficient is basically the correlation between the number of confirmed cases and the number of deaths. And you see it's more than 50%, more than 0.5. So it means it is somehow, I don't know how, we don't know how yet because we don't have enough data in order to analyze that. But it's somehow related. It could be the hospitals, because when the number of confirmed cases increases, people die because they cannot access all those facilities because they are always preoccupied by the people who are already infected.
I think it's because of the government. They don't know how to manage this, right?
Could be.
The second question is, what is global infection rate per day?
So infection rate is basically how much people, in getting infected in a single day. So let's say yesterday it was 15 people, and tomorrow we have 20 people, right? So now you will say the infection rate
in one day
it's basically 20 minus 15, which is 5 people per day. And as that number is getting changed every day, so you see this rate is been fluctuating.
Let's see what happens here in the data. Okay, so I plot this. Firstly I calculate the rate here, and I plot the graph, and this is the result. So what do we have here, Sunshine?
So in the x-axis we have the days again, and in the y-axis we see the number of infection. Right. You see, it looks like the number of infection rate, it goes up sometime, it goes down, right? Because you don't have a consistent number of people getting infected in a single day. Okay. But here, which is very surprising, so in one day, there were around 15,000 people they got infected in a single day. And the next day, you see there is more than 5,000 people who did not get infected.
Okay. So you mean based on the yesterday?
Yeah, based on the yesterdays. So basically, we can say that the number of people getting infected is very fluctuating, and the point is that you can have a,
let's say, good news.
Good news is that as today it's 11th of the March, the infection rate is going down. But we always have to consider what is the death rate, because people who are already infected, they are dying. So we have to calculate the death rate as well. So.
Okay, so if you move forward, the third question is, what is the rate of death every day in the whole world?
Okay.
So this is the plot that we have. And I think here, as you can see, in the 11th of March, we have a good plot. I mean, it looks good.
So it is, as you can see, this graph, this number of deaths is pretty similar as well.
Yeah.
So I don't know, in some sense, I believe there's this number of people getting infected. And number of people getting, dying every day, the rate, they're related. So what we have discussed before, the infection rate, so it actually tells you the truth that they are related somehow. We don't know how. We have to know
they're related.
somehow. So guys, please stay tuned for much more information about it.
Yeah, we're gonna discuss it also tomorrow. We're gonna have another video, maybe a series of videos about coronavirus in different regions of the world. I guess. Thank you so much for watching this video. Stay tuned. Bye bye.